This is an example of how to use the coefficient of kinetic friction and the coefficient of static friction to solve problems. So go ahead and take a moment, maybe pause the video to read the actual problem statement. So my first step is going to be to draw the pineapple, draw a picture of the situation. So here's my pineapple, here's the leaves. And I'm going to just talk out loud about my thinking process so you can sort of see what it's like to approach these kinds of problems. And a baby came along and is pulling on the leaves of the pineapple with a force of 4 newtons. And the question is, we're supposed to determine the force of friction on the pineapple and the acceleration of the pineapple. So let's see, we can think about what's happening here. The acceleration of the pineapple. Well, I don't really know if it's moving. How would I know if it's moving? To know if it's moving, I would have to compare the force of the baby on the pineapple with the maximum force of static friction. So there's friction pulling this direction. As the baby tries to pull the pineapple to the right, friction is going to oppose that attempt to move the pineapple. And the pineapple will move if the force of the baby is more than the maximum force of static friction. So I probably need to find the maximum force of static friction and then compare these. Force of friction static maximum is the coefficient of static friction times the normal force. So I don't know the normal force. Well, let's think about the vertical forces on the pineapple. So we have force of gravity pulling downward on the pineapple, and we have a normal force of the surface pushing up on the pineapple, and those forces are equal in magnitude because the pineapple's not accelerating up or down. So in the vertical direction we have balanced forces. So maybe I'll go ahead and find the force of gravity, because if I could find the force of gravity, I know that's going to be equal to the normal force. So the force of gravity on the pineapple is the mass times g, and the mass of the pineapple is 900 grams. And if I think about it, I'm wondering if it's okay to use grams. So G has units of newtons per kilogram, so I think I better convert to kilograms. So be careful about your units. So 0.9 kilograms times 9.8 newtons per kilogram. And let's calculate that. So 0.9 times 9.8 is 8.82 newtons for the force of gravity. And then since the vertical forces are balanced, I know that the normal force must be equal to the force of gravity. And the force of gravity was 8.82 newtons. So now we know the normal force, which I can substitute here. So remembering what I'm trying to do, I'm trying to find out if the pineapple is going to move. And so I need to know if the baby's force is more than the maximum force of static friction. So I'm trying to calculate the maximum force of static friction. So I need the coefficient of static friction, which is 0.38 times the normal force, which I just found. And calculating that, we have 0.38 times 8.82, which is 3.4 newtons. So this force of static friction has a maximum value of 3.4 newtons. But the baby is pulling with 4 newtons. So it looks like we have a larger force here than the static friction can balance, and so it's going to move. So it moves because the force of baby is greater than the maximum force of static friction. So now that it's moving, we know that it's moving. What kind of friction force is on the pineapple? Well, if it's moving, we must be having kinetic friction on the pineapple. And so we need to calculate how much the force of kinetic friction is. So the force of kinetic friction equals the coefficient of kinetic friction times the normal force. So the coefficient of kinetic friction was 0.29. The normal force was 8.82 newtons. So let's calculate that. 0.29 times 8.82 is 2.6. So the force of kinetic friction on the pineapple is 2.6 newtons. And it says determine the force of friction on the pineapple. So since it's moving, this is going to be the amount of the force of friction on the pineapple. Now it also says to find the acceleration of the pineapple. So to find the acceleration of the pineapple, I'm going to go back over here near my free body diagram. And since it's moving, I've got the baby pulling to the right with 4 newtons. And it's moving, so I know now that this is kinetic friction. And that is 2.6 newtons. So I need to, it looks like I have unbalanced forces here. So unbalanced forces means that we have a changing velocity, which is an acceleration. So in order to calculate that, we need to use Newton's second law. The net force on the pineapple equals the mass of the pineapple times the acceleration of the pineapple. So the net force is going to be all the forces to the right minus all the forces to the left. So 4 newtons minus 2.6 newtons equals 0.9 kilograms times the acceleration of the pineapple. So we need to subtract 4 minus 2.6, which is 1.4 newtons equals 0.9 times the acceleration. And dividing both sides by 0.9, we get 1.6 meters per second squared for the acceleration of the pineapple. So to review what we did, we started out by drawing our force diagram and thinking about how we're going to know what kind of motion it has. Since it was started at rest, in order for it to move, the force that's applied to it has to be more than the maximum static friction force. So we had to find the maximum static friction force before we could know if it was even going to move. Once we found that, we could compare and know that, well, 4 newtons is more than the maximum static friction force. So it's going to start moving. And if it's moving, then we have kinetic friction acting on it. And to find the acceleration, we need to find the net force, which was the force of the baby minus the force of friction, equals mass times acceleration, and we could find the acceleration of the pineapple. In problems like this, where there are many steps, you probably won't be able to see your pathway from the beginning of the problem to the end at the time you start the problem. So problems like this, you usually will find your pathway as you go. And so start by drawing your force diagram. Calculate the things that you know you can calculate. If you can calculate the force of gravity, do that. If you can find the normal force, do that. Those things are always related to finding the frictional forces. And just find your way one piece at a time, and you'll get eventually to the solution.